Listen to me, because this is not a joke. It is possible that 5G, yes, that same one that was so much talked about in 2020, will completely destroy aviation as we know it. The FAA has already issued a statement, and in this video we will explain what is happening. Let's start from the beginning. For a plane to land safely, it has to see the runway. Obviously, that's clear, but what happens when weather conditions prevent it? What if there are very low clouds? Or if there is a lot of fog? This is where the navigation instruments and radio aids on the ground come in place, which will help the pilots get the plane safely to the runway. When these conditions occur, there is a decision altitude at which the pilot must abort the landing if he does not see the runway. And normally in large airports there are systems that practically allow the plane to land completely automatically. And this is where the pilot comes into play, who will check that once the plane reaches the decision altitude, the runway is visible. Otherwise the pilot will abort the landing. The more precise the systems that guide the aircraft on landing, the lower the minimums on the decision altitude, and the worse the weather conditions accepted to land. For all this to happen, the aircraft, the crew, and the pilot have to meet certain requirements in order to have the necessary reliability for this type of landing. It must be taken into account that each country and each airport can be more rigorous with these minimums when landing. But not only that, but in the different airports deal with different conditions that will make the minimums change. For example, this is an aeronautical chart for landing on runway 18L at Madrid-Barajas Airport using ILS. Depending on the instruments used, three types of landing can be carried out. ILS Cat 3A, where the minimums are 50 feet, which means that if the aircraft is at 50 feet above the ground level and the runway is not visible, the landing must be aborted. Then there is Cat 2 with 113 feet minimums, and finally ILS plus TME 229 feet. That is also known as ILS Cat 1. As you have seen, these minimums are smaller in the approaches called ILS Cat 3B. But what is this ILS and those categories? Well, let's get on with it. The ILS, from the acronymous Instrumental Landing System, is, as you know, a navigation system to assist in landing. It is the most accurate system used at the commercial aviation level. It is true that at the military level there are other systems, but let's not go in detail here with it. The ILS consists of a system of radio aids on the ground and antennas on the aircraft. The radio aids on the ground are fixed with respect on the ground and are positioned in such a way that they emit radio waves with which two planes are generated. These planes intersect and create a straight line with the perfect glide slope, and if the aircraft follows it, it will land in the optimal place on the runway. On the one hand, we have the localizer, which emits directional signals creating a vertical plane, which indicates the course or direction to follow to the runway, and on the other hand, we have the glide path antenna, which emits a plane with a certain angle with respect to the ground or angle of descent, which the aircraft will follow to descend until it reaches the runway. Generally, the aircraft automatically positions itself on the straight line and makes the landing. But there also exists the case in which the pilots manually follow the indications given by the ILS. The interesting thing here is that there are several categories of ILS, each one more precise, and therefore the minimums will be lower. There are ILS categories Cat 1, Cat 2, Cat 3A, and Cat 3B. But there is also a Cat 3C, having the capacity of landing with zero visibility, but this is not used in the civilian level. Basically, having more redundant systems, safer radio ground aids, and more trained crews will make it possible to perform more precise approaches. For example, an aircraft that intends to land in Cat 3B category will need 3 autopilot systems, 3 flight computers, and 3 radial altimeters, and will need more such redundancies. On the other hand, the pilots who will make that approach need to have relevant courses to enable them to do it. Or if an airport wants to be able to have this type of approaches as a possibility, it will need to have backup power generators, redundant systems, lightning systems, you name it. For example, it cannot be the case that an aircraft landing in bad weather conditions is left without ILS due to a power failure on the ground. All these systems must be autonomous and redundant. Let's go with an example. In the most precise category of all, Cat 3B, if the autopilot is operating on approach, the aircraft will reduce engine power, make contact with the runway and stay aligned with the runway axis, all automatically, while the pilots monitor this maneuver in detail so that in the slightest case of doubt about what the autopilot is doing, the landing could be aborted. After talking to several pilots, they've told us something very interesting. When they make a landing with ILS, what they have in mind is that the landing will be aborted, and they must be prepared for so, and only if they see the runway before the minimum high, the landing will be carried out. It is not that they carry the approach thinking about landing and if they don't see the runway, they will abort. No, it's completely the opposite. The initial mentality is to abort, and only if the runway is seen before the minimum high, they will continue with the landing. So interesting. It should be noted though that in very windy situations, or for example in different emergencies, this type of landing cannot be done automatically, since the autopilot is not able to control the aircraft and must be done manually by the pilots. Well, we finally got to the important point of the video. For the plane's autopilot to have a very accurate measurement of the distance to the ground and for the pilots to know whether or not to abort the landing, it is necessary to know the height with respect to the ground in an almost perfect way. For this is used the Radial Altimeter, an instrument that, thanks to radio waves pointing to the ground, manages to measure the vertical distance with respect to it in a very precise way. Since, in a sense, knowing that the waves travel at the speed of light and timing how long it takes to arrive, you can know the distance. This instrument will tell the pilots the altitude at all times, and with this data, the plane will also know what to do in the case of automatic landing. Well, once we have talked about landing approaches, let's go to the other part of this video, to understand what is the 5G, to see how both points conflict in some circumstances. We will not go into detail because it is not the topic of the channel, but in a sense 5G is known as the 5th generation of mobile networks, which is already operating throughout the world in a generalized way. The advantages of 5G are immense in terms of internet speed, but in reality the previous 4G networks are already very fast at level of user. So both you and I, when sending messages, with the 4G we were already very satisfied. However, with the 5G it is so fast that allows the interconnectivity of devices to a level never imagined. For example, it could allow the new generation of autonomous cars to communicate with each other or perhaps make traffic lights disappear by communicating with each other perfectly. The synchronization to cross a street would not be necessary to do it waiting, but the cars could synchronize with each other to go to a certain speed and thus reach the crossing point in a time in which it is estimated that there will be no one. This is just an example to give you an idea of what 5G can allow with this incredible communications speed. It is not a simple improvement of the mobile network. Going from 4G to 5G would not be like going from an iPhone 10 to an iPhone 12. The example is similar to going from a Nokia of those that could fall to an iPhone 13. The bad part here is that 5G brings some problems. It turns out that many more 5G towers are needed to be installed than the existing 4G towers. At first, this does not have any problem within itself, but you will see that in reality it does. And in addition, to further improve connectivity, new frequencies are being incorporated into the network. That is, for the information that is sent over the network to be separated into different frequencies, and thus the internet will go faster. As for example in the United States from December 5, 2021, and here is exactly where the problem appears. Because they have decided to start to operate in the frequency range of 3700 to 3980 MHz. And the problem is that the radio altimeters, those that we have mentioned earlier, operate in the frequency range from 4200 to 4400 MHz. As you can see, there is very little range in between. First of all, the aeronautical sector feared that this wave frequency could generate interferences with the radio altimeter. And this is exactly what ended up happening. But we are not talking about minor failures. We are talking about the radio altimeter no longer being usable, and many types of approaches that require the radio altimeter cannot be carried out, as they depend on the radio altimeter to know the height of the aircraft with respect to the ground. This implies that on a day with low visibility, for example with low clouds, where they have to use the ILS to approach, many aircraft would not not be allowed to land on those airports. However, if the visibility is okay, there would be no problem, because that only affects the radio altimeter. But also remember that I have said that the 5G will require more 5G towers than the existing 4G, and this is the problem that can be generated. It can literally destroy aviation if something is not done.
And this is where the usual problem appears. Interests, as always, because in reality we don't have enough information to say that the 5G network is causing the interferences. We know that there are interferences and they may be because of the 5G network, but we haven't performed real tests to confirm that. The Radio Technical Commission for Aeronautics is an American non-profit organization that, through volunteers, helps the FAI with those situations in which the FAI is not expert. Those things about the communications and the radio waves and all those things, those people are expert and not the FAI, so they help them. So they carried out a study about the interferences with the radio waves and the altimeter, and this is what they found.
Paying attention to the Chicago International Airport, they looked at how many 4G towers there are today near the airport, and theoretically, throughout simulations, they replace them with 5G towers, and they see if they generate or not interferences. And this is what they found. This is the most important graph. On the x-axis we have the altitude of the aircraft, the y-axis marks the amplitude of the interferences, and the lines of different colors mark the interference generated by each 5G station. For example, the purple line refers to the station closest to the airport, and when the plane passes just above it at about 275 feet, it generates huge interferences. The next station is the yellow one, and so on. Well, for large aircraft, the acceptable limit is marked by this band. However, for medium aircraft, it is marked by this band, which means that all stations would leave out of service the altimeter of a small aircraft. And for large aircraft, it exceeds on several occasions, and it is explained that this can lead to 4 situations. Both radars are inoperative. Only one of them remains inoperative, or both continue to operate giving wrong signals, but each radar has different signal and therefore the pilot would see that there is something wrong. And the last case that left me perplexed is that the interference may cause both radars to have wrong readings but both giving the same reading. So there could be no way to realize that there is an error. So maybe if you are at 250 feet, your plane will think that you are at 100. Think how could end up this. But here's where the interesting part comes. 5G Americas is an organization that advocates for advantage and development of the 5G, and they put out a document where, surprise surprise, they stated that 5G networks do not mess with altimeter signals, and they literally say that sufficiently well-designed equipment should not receive interferences under any circumstances. And in fact, they say that if it's necessary, the airline industry should take action and basically change the frequencies on which they work.
The thing is that from this 5G Americas organization, they only want the prosper of the 5G. They don't care if the 5G interferes with any systems in the aircraft. Apparently, they literally don't care if this causes any damage on aviation. When aviation came first, we were here before 100 years ago, and so the technology that is inside the aircraft. It doesn't make any sense now to change the frequencies that are used inside the airplane just because they are going to be used by a 5G network.
However, in aviation, we cannot allow a single error, and that is why on December 23, 2021, the FAI issued an airworthiness directive on the subject. These airworthiness directives are like rules that the authority issues and must be respected. For example, when all the 737 MAX were forced to go to the ground due to the accidents, it was done throughout airworthiness directives. Well, in this case, was to prohibit certain approaches that make use of the radio altimeter at airports that have near them those 5G towers.
Luckily for us, in the end, they have decided to not use those frequencies that interfere with the altimeter. Well, as I'm reading, they have just decided to not use those frequencies near the airports. So I suppose that when we better study those situations with real tests in the real world, with real aircraft, not just in the laboratory, well, decisions will be made. But for the moment, temporary, those networks are not going to be used near the airports. It's very likely that after this video, or even after I recorded this part, new information will come. So I recommend you to follow me in my social network, and of course follow this account, subscribe to this channel, because we're going to make incredible videos. Thank you so much for watching this video, and remember, as always what? Yeah, to think supersonic.